Okay, let's begin. Start करते हैं. So today's topic is kinematics and calculus. There are about 10 examples in this. As soon as those examples are done, class को wind up करेंगे फिर. If there are any questions, please keep asking as we go on. Okay, I can see this chat and everything. And in case you miss anything, आपका internet बंद हो जाता है, कुछ और हो जाता है, so please make sure that you are watching this on YouTube later on. मैं stream कर रहा हूँ, record हो जाएगी वहाँ पे, and you should be able to see it. Okay, so kinematics and calculus is a continuation of kinematics and constant acceleration. हमने last class में जो है वो we did kinematics के graphs, speed time, distance time, displacement time. वो सारे graphs देखे थे. उसके बाद हमने constant acceleration formulae पढ़े थे, which are given in your formula sheet as well. और जो है हमने अब कंटिन्यू करना है काइनेमैटिक्स एंड कैलकुलस. व्हेन आई से कैलकुलस आई मीन बेसिकली डिफरेंशिएशन एंड इंटीग्रेशन. दिस इज अ फील्ड ऑफ मैथमेटिक्स दैट यू हैव ऑलरेडी डन. आपने कभी इस हेडिंग के नीचे नहीं पढ़ी होगी, बट आई एम टॉकिंग अबाउट डिफरेंशिएशन एंड इंटीग्रेशन. ओके, सो व्हाट इज द कनेक्शन बिटवीन काइनेमैटिक्स एंड कैलकुलस? हम कहते हैं कि इफ आई हैव अ डिस्प्लेसमेंट टाइम इक्वेशन, डिस्प्लेसमेंट टाइम है मेरे पास, मैं अगर उसको डिफरेंशिएट करूंगा, it's going to become, let me write this here properly. If I differentiate this, it becomes velocity time. And if I differentiate this further, it becomes acceleration time. ओके, तो हम कहते हैं कि भाई अगर आप एस टी को डिफरेंशिएट करें तो वो वी टी बन जाता है, एंड वी टी जो है वो फिर डिफरेंशिएट होके ए टी बन जाता है. ओके, व्हाट इफ यू वांट टू कम बैक, इफ यू वांट टू कम बैक फ्रॉम ए टी टू अ वी टी, यू इंटीग्रेट, रिवर्स प्रोसेस आप चलाएंगे, and then you integrate again. Okay, whenever you're integrating, one important component is always the plus c. So you have to be careful कि आपने plus c जो है वो incorporate भी करना है, इसको सही से calculate भी करना है. Remember that c is not always the initial condition. It depends on the equation that you have. C can be anything depending on what coordinates are available to you. Sometimes it's going to be zero, sometimes it's not necessarily zero. So please think about it before you conclude that what the value of c is basically. Okay, the first says, a example says a particle starts from point O and moves in a straight line so that its distance s centimeters from O after time t seconds is given by this, its initial velocity and acceleration. Okay, so this is an ST equation. Okay, I see this is a cubic equation for me. It's initial velocity and acceleration. Whenever I say initial, I mean time equals to zero. So I'm going to say that time zero. That's what I want to calculate. I want to calculate the velocity and acceleration, which means that I'm going to differentiate this. When I differentiate this, it's going to become a VT equation. So VT would be 4t minus 3t square over 6. Okay, that's a VT equation. What do I need? I need to plug in 0, and I'm going to say that the initial velocity is 0. Okay, then if I differentiate this further, it's going to become 80. So 40 differentiates to 4, and this becomes 60 over 6. Okay, for initial, again, I'm putting in 0, so the initial acceleration is 4 meter per second square. Okay, so whenever I say initial, आपने t को 0 रखना है, and that is how you would calculate. Okay, It's time after the start when it comes to a momentary halt. What do I mean by a momentary halt? A momentary halt simply means that v equals to 0. So in the second part, I'm going to say that v equals to 0. Remember that whenever you put in v equals to 0, is 3t squared over 6. You will end up with an equation that you'll have to solve. So this is t squared over 2. This is a quadratic equation. I'm going to solve it. Uh, Whichever way I find convenient. I see that I can factor out the t, 4 minus t over 2. If you think you want to use a quadratic formula, that's up to you. 4 minus t over 2 equals to 0. So t equals to 8. So after 8 seconds, the velocity will be 0. Now remember that whenever the velocity will be 0, particle will turn around. Remember that. सही है अब आगे इसके distance displacement जो भी निकालना हो, this is something that you need to be careful about when you are saying that v is ever 0 हो गई है. It's distance from O at this time. Okay, at this time, the time that you just calculated, so I am asking you the displacement at t equals to 8. So s equals to 2 8 squared minus 2 cube over 6. What am I getting? क्या बताऊं? Sorry. Its distance from O. O is the origin, yes. So मैं displacement निकाल रहा हूँ. Displacement is from the origin. Okay, I have to calculate. Okay. Um, so I have to do 2 into 64 minus 8 over 6. 380 over 3. Is that the right answer? 126.7. Abir, yes, you would reject. After the start, kind of, so t equals to 0 will be the start, and t equals to 8 will be the point where you come at a momentary halt. Okay? Okay. D. What maximum velocity does it reach before the time? When do you reach maximum velocity? Now remember that maximum and minimum are the same ways that you find stationary points in differentiation and integration. If I am asking you to find out the maximum velocity of maximum point of this curve, basically t square over 2, what you're going to tell me is that k, so differentiate करें and then equate it to 0. So if you differentiate it, it becomes dv over dt, which is actually a. So dv over dt equals to a बन जाएगा, and let's calculate dv over dt. This is something that I've already done, but I'm doing it again just to show you कि भाई मैंने differentiate किया तो ये a बन गया. What am I going to do? Whenever I say maximum velocity, that automatically means that acceleration is equals to 0. बिकॉज कॉन्सेप्ट वही है कि मैं टर्निंग पॉइंट फाइंड कर रहा हूँ. ओके, सो टी इक्वल्स टू 4 पे जो है मैक्सिमम वेलोसिटी रीच आ गई है. हाँ, मैंने आई थिंक आई डिड सम कैलकुलेशन रॉन्ग और व्हाट. अच्छा, मैंने 2 क्यूब लिख दिया. ओके, सही है. ओके, थैंक यू. Okay, 128 over 3. Yeah, I was thinking there was something wrong with the answer. Okay. Okay, so t equals to 4, what maximum velocity? Now, what maximum velocity does it reach? I'm going to say that 4 times 4 minus 4 square over 2. So that's 16 minus 8. That's 8 meter per second. So it reaches its maximum velocity at t equals to 4. And when it reaches its maximum velocity, the actual velocity is basically 8 meter per second for time 4 पे हो रही है. Okay? After what time does the particle pass through O again? What do you think this should be? Abir, I said maximum velocity जब कब reach होती है जब acceleration zero हो जाती है. ग्राफ का टर्निंग पॉइंट जो VT ग्राफ का टर्निंग पॉइंट होगा उस पर एक्सेलरेशन जीरो हो जाएगी. सही है. विच मीन्स इसका डिफरेंशियल जो होगा वो जीरो हो जाएगा. सही है. जब डिफरेंशियल जीरो हो जाएगा तो वेलोसिटी फिर मैंने निकाल लिया. इसके हिसाब से टाइम आ गया और वेलोसिटी निकाल ली. ओके. ओके. पार्ट ई. Part E says after what time does the particle pass through O again? So whenever you pass through O, what happens is that S equals to 0 हो जाता है, displacement 0 हो जाती है. So let's make displacement equals to 0. So 2t square minus t cube over 6. How do I solve this? Either you can go on and solve your cubic equation on your calculator, but exam में थोड़ी working दिखानी होती है. So I've taken a t square common. I said either t square equals to 0 or 2 minus t over 6 equals to 0. T equals to 12 हो गया. Okay. So I have at t equals to 12, the particle is going through O again. Now I want you to understand that if I was to draw this journey, ये कैसी जर्नी दिखेगी. सही है. आई एम ड्राइंग इट हियर. व्हाट हैपेंड एट t इक्वल्स टू 0 पे जो है वो पार्टिकल ने यूं करके मूव करना स्टार्ट किया. सही है. एंड एट t इक्वल्स टू 8 it had come to a momentary halt. Momentary halt मतलब it stopped for momentarily and then turned back. Whenever you have v equals to 0, the particle has to turn back. So at t equals to 8 जो है the particle turned back and started going like that. Okay. And then it went like that. Okay. When did it reach O again? It reached O at t equals to 12 again. इसके बीच में एक ऐसा टाइम आया था t equals to 4 जहाँ पे velocity maximum हो गई थी. ओके. और एक्सेलरेशन जो है वो जीरो हो गई थी. सो ऑल ऑफ दीज थिंग्स प्ले आउट. अगर मैं आपसे पूछूं कि भाई व्हाट इज द टोटल डिस्टेंस ट्रेवल्ड, then it's going to be a question about distance. You cannot calculate distance directly. You will have to calculate distance by um, saying that S जो है वो कैलकुलेट करना पड़ेगा पहले T8 पे. तो पूरा वापस घूम के आया है तो भाई उसको डबल करना पड़ेगा. सो डिस्टेंस जो है वो कैलकुलेट करने में स्टेप्स होते हैं. आगे सवाल आएंगे एंड विल टॉक अबाउट द इंटायर जर्नी. देन कि भाई पूरी जर्नी को आपको जब तक आप ड्रॉ नहीं करेंगे तब तक आपको जर्नी नजर नहीं आएगी. ओके. एनी क्वेश्चंस so far? So this is the crux. This question builds the entire idea of kinematics and calculus. Abir, you were saying something. Okay. And can I take you to the next question? You can probably copy later. You have the access to the PDF. You can do it. I don't want to take this lecture very long because it's going to take time to. Uh, okay, moving on. Just hold on for a moment. सर डिस्प्लेसमेंट को डिफरेंशिएट करने पे वेलोसिटी फाइंड होती है. कैन यू एक्सप्लेन व्हाट इज मेंट बाय डिफरेंशिएशन ऑफ डिस्प्लेसमेंट टाइम? डिस्प्लेसमेंट टाइम का बेटा इक्वेशन है ना. इस इक्वेशन को डिफरेंशिएट करोगे तो क्या आ जाएगा? ds ओवर dt आ जाएगा. ds ओवर dt मैं कह रहा हूँ v होता है एक्चुअली. दैट्स व्हाट आई एम सेइंग. अभी बता रहा हूँ. बता. लेट मी जस्ट स्टार्ट ऑफ विद दिस क्वेश्चन. ओके. Okay, so the second example says the distance s meters of a particle moving in a straight line measured from a fixed point O. So your starting point is O. On the line is given by s equals to, फिर से s t वाली equation दी हुई है, s equals to t square minus 3t plus 2, where t is the time in seconds from the start. Find its initial distance from O. So it's telling you that this equation is from O, but the particle was probably standing away. So initial का मतलब तो हमेशा t equals to 0 होता है. So मैं क्या करूँगा? 0 square minus 3t plus minus 3 into 0 plus 2. Okay, so I get 2. Okay, its initial velocity and in which direction. So पहले तो मैं initial velocity पे काम करता हूँ. I know that if I want to get vt from st, I have to differentiate. So this becomes 2t minus 3. When I plug in t equals to 0 in this, I get minus 3. Negative velocity का मतलब होता है, वो हमने velocity time graphs में भी देखा था. Whenever the velocity is negative, the particle is the vt graph was below the x-axis और particle क्या कर रहा होता था? Reverse में जा रहा होता था, यानी it was moving towards O. Okay, so what is this particle doing? If I start to model the journey, ये O है. यहाँ पे t equals to 0 पे जो है वो particle 2 meters दूर खड़ा हुआ है. Okay, what does the particle do? It starts its journey like that. Okay, it starts its journey like that. How do I know? Because my velocity came out as minus 3 meter per second, which means that the particle is moving in the opposite direction to what it naturally does. हम naturally assume करते हैं कि वो right की तरफ जो है वो move करना start करता है. Okay, okay, then part C. So in the direction towards, oh, let me write that too. Part C, its initial acceleration. Again, I want acceleration, so I'm going to do what? I'm going to differentiate. I'm going to say that this becomes 2. So that's constant, which means that the graph has constant acceleration, meter per second square. Okay, part D, the times when it passes through O and with what velocity. When does it pass through O? When displacement is 0. And with what velocity? So I'll have to use those times to find the velocity. So I'm going to say that this becomes s equals to t square minus 3t plus 2. 0 equals to t square minus 3t plus 2. Now what I can do is on my calculator, I can find out my, okay, so I have 1 minus 3 and 2. So I have 1, 2 and 1. So time 2 and time 1. So what the particle is doing is it's passing through O at these 2 times. I'm going to draw the graph for you in a little bit. मैं clear cut थोड़ा सा graph draw करके दिखाऊंगा because I'm short on space here. I'll move this up and later I'm going to draw this graph. Right now I just wanted you to know the times. So I found out the times, but I didn't only want the times, I wanted the velocities as well. So what is the velocity? It's 2 times 2 minus 3. The velocity is now 1 meter per second, and velocity here was minus 1. Okay, when and where is it at instantaneous rest? So momentary halt and instantaneous rest are the same thing. Instantaneous rest कब आ रही है? Instantaneous rest होती है v equals to 0 कब हो रहा है? when is the velocity equals to 0. So I'm going to use my velocity equation, which is 2t minus 3. I'm going to say that this is equals to 0. So t जो आ गया वो 1.5 आ गया. So when and where? So when आ गया time 1.5, where how do I find out where? I'm talking about displacement, so I'm going to say that this is 1.5 square minus 3 times 1.5 plus 2. Okay, let's quickly calculate that on our calculators. uh, where पूछा है ना उसने, where बता रहा हूँ मैं. where का मतलब क्या है, इसकी पोजीशन क्या है? minus 0.25. What does minus 0.25 mean to you? माइनस 0.25 का मतलब क्या है कि वो जो है वो ओ से पीछे चला गया है. ओकाशा में बता रहा है कि बिहाइंड द ओरिजिन है. यू आर राइट ओकाशा. सो व्हाट हैज हैपेंड इज के पार्टिकल ने टाइम 0 पे स्टार्ट किया, वो 2 मीटर दूर था. पार्टिकल जो है वो जाता रहा कब तक पीछे, जब तक उसने टर्न ना किया. उसने टर्न कब किया है? उसने टर्न किया है 1.5 पे. यहाँ पे से वो कब गुजरा है? वो टाइम जो था यहाँ पे 1 सेकेंड हुआ था. सही है, टाइम 1 सेकेंड हुआ था, तब वो यहाँ से गुजरा था. जब टाइम 1.5 हुआ तो पार्टिकल ने टर्न किया था. पार्टिकल ने टर्न किया और फिर दोबारा पॉजिटिव डायरेक्शन में जाने लगा. जब टर्न करके वापस आया तो जो है टाइम 2 हो रहा था. ये भी हमने निकाला था कि 0 पे कब कब पहुंचा है, टाइम 2 पे पहुंचा है. अब उससे आगे जो है वो मैं अज्यूम करूंगा कि यूं ही जाता रहेगा. कितना आगे जा रहा है अभी मुझे नहीं पता. आई कैन फाइंड दैट आउट इफ यू वांट, but that's not something that's asked in the question. Okay, so that is what is happening now. If I can ask you various things. I can ask you कि भाई what was the distance traveled. What you'll tell me is कि सर ये distance अभी आपने 0.25 निकाला है. So पार्टिकल ने क्या किया होगा? पार्टिकल पहले 2 मीटर पीछे आया होगा ओ तक, तो उसने 2 का डिस्टेंस ट्रैवल किया होगा, फिर वो 0.25 और पीछे गया होगा, फिर वो घूम के जब आगे गया तो उसने 0.25 और ट्रैवल किया होगा. सही है, वो एक ही डायरेक्शन में ट्रैवल कर रहा है, वो मेरी तरह इस तरह राउंड अबाउट से नहीं घूम रहा. द पार्टिकल इज गोइंग लाइक दैट एंड दैट. सही है, इट्स नॉट sort of taking U turns. It's just going along that same road. हम पार्टिकल ट्रैवलिंग इन स्ट्रेट लाइन की बात कर रहे हैं, और ऊपर लिखा हुआ भी होगा पार्टिकल मूविंग इन स्ट्रेट लाइन. ओके, that's what the question says. So but the particle is not turning, कोई U-turn नहीं ले रहा कि आप उसकी भी length measure करके मुझे बताएं. It's just going back and forth like that. Okay, so I can calculate the distance traveled. एक एक करके चीजें add करनी पड़ेंगी if I really want to do that. Or there is going to be a shorter way out as well, and we'll think about this in a later question then. Okay. Okay. Then it says the velocity v meter per second, v centimeter per second of a particle moving in a straight line is given by this. Now, instead of telling you the st equation, I've told you the vt equation. V equals to 6t minus kt square, where k is a constant and t is the time in seconds from the start. If the acceleration is 0 when t equals to 1, find the value of k. So the acceleration is 0. I have data on acceleration. I have the vt graph. Should I differentiate this first? I can say that when I differentiate this first, I get 6 minus, this is kt squared, right? Kt squared minus 2 kt. Then I can use this value that when a is 0, t is 1. So 0 equals to 6 minus 2k into 1. 2k equals to 6, k equals to 3. Okay, so at k, for the value of k pucha tha, there's no meaning to this value of k. That's just a value, it's a constant in the equation. Okay, then part B says the time when the particle comes to instantaneous rest. Instantaneous rest is again v equals to 0. So 0 equals to 6t minus 3t squared. So t common, 6 minus 3t, t equals to 0 or t equals to 2 आ रहा है मेरे पास. Okay, so at these 2 points in time the particle was at instantaneous rest, which means that the particle must have turned. घूम के आया है वो वापस. Okay, and we'll talk about that. Um, okay, the time when the particle comes to instantaneous rest, that's what I've told you. The maximum velocity of the particle. The time, yes. उसने after the start नहीं करना, तो अभी दोनों ही लिखूंगा. Okay, part C. The maximum velocity of the particle. What is the maximum velocity of the particle? When a equals to 0, the maximum velocity हो जाती है. That's what you were talking about in the earlier um, example. The maximum velocity of the particle. So v equals to 6t minus 3t squared. I have differentiated this already. 6 minus 60. Okay, maximum velocity is when a equals to 0, so t equals to 1. Okay, now I can't draw the same diagram that I drew for you earlier. Why? Because उस वक्त मेरे पास ST की equations थी. अभी मेरे पास जो है I don't have ST equations, I have the VT equation. If I really want to draw a diagram for you, पहले मुझे ST की equation निकालनी पड़ेगी with the points that I have available to me. It's going to be a difficult job because कुछ मुझे missing data भी नजर आ रहा है. So therefore this question is not about drawing up an ST equation. Okay. Um, Okay, since my Zoom is a little tricky right now, this meeting is going to end shortly, and you'll have to join back again for the next half of the class. So what we're going to do is we're going to take a short 10-minute break for you to digest all of this, and then we're going to continue with the other examples. Okay, so let me come back in 10 minutes. It's 10:55 right now. Let's join back at 11:05. Okay, so let's start again. We left this on example 3. Let's go on to example 4 now. It says the velocity in meter per second of a model train which is moving along straight rails is v equals to this. Find its displacement from its initial position after time t. So this is a sort of awkward question कि मैंने आपको कोई time नहीं बताया. So what I'm actually asking you to find is an ST equation. Okay, how do you find an ST equation? If you have a VT equation, what should I do to this equation in order to obtain an ST equation? Okay, as we studied before, मैं इसको अब integrate करूँगा. When I integrate both sides, this side becomes S. Okay, and this is going to become 0.3 t cube over 3 minus 0.5 t plus c. Now always plus c will be there. Remember that you cannot eliminate plus c directly. So what you need is whenever you have to find c, पहले भी integration के अंदर तो आपके पास कोई एक coordinate available होता था. What coordinate do I have available here? And it's going to be there in the information. It's not uh, something that अक्सर explicitly नहीं state किया जाता, कहीं कहीं explicitly भी state किया जाएगा. But in this question, if you notice, it says displacement from its initial position. So what it's telling you is that when t equals to 0, the particle was at O, let's say. So yeah, or whatever its initial position was, I'm calling it O right now. So that automatically means that the coordinate that I have available is t equals to 0 and s equals to 0. कहीं कहीं ऐसा भी होगा, the question will tell you that the particle was standing 5 meters away from O or starting 3 meters behind O, for example. So in that case, you'll have to, sort of adjust the numbers and then come up with a final answer for me. Okay. So in this case, it's simple. I'm going to say that when I plug in 0, everything becomes 0. Therefore, C is also 0. So the what is the relationship? What is the displacement? Find its displacement after its initial from its initial position after time t. So I'm going to say that it's zero point 0.1 t cube minus zero point 0.5 t plus 0. Okay. After 3 seconds, let's find out after 3 seconds. Okay. So I think that should give you 2.7 minus 1.5. That's 1.2 meters. Okay. Relatively simple question. Let's see the next one. It says the acceleration of a particle in meter per second is given by this. The particle is initially at the origin with velocity this. Find an expression for the velocity of the particle after t seconds. So I'm asking you to find an expression, which means that I'm asking you to integrate. Okay, so I get v equals to 6t minus t square over 2 plus c. Now, how do I find plus c? Look at the information that's given. It was initially at the origin with velocity minus 2. So that means that the velocity was minus 2 when time was 0. So you can't just simply say that c हमेशा 0 होगा. C यहाँ पे minus 2 आ गया. So what is my velocity equation is 6t minus t square over 2 minus 2. I again have to integrate this when I have to find the position of the particle after t seconds. Part B के लिए. Okay. So part B, let me solve that here. 6t square over 2 minus t cube over 3 minus 2t plus c. Okay, let's call that plus d just so that it doesn't confuse you. Okay, then what am I going to do? I'm going to say that still have to find this d. So it was initially at the origin, which means that the displacement was 0 when time was 0. So 0 cube over 3 is everything becomes 0, I think. So d is 0 then. So s equals to 3t square minus t cube over 3 minus 2t plus t. Hence find the velocity and position 6 seconds later. Hence find the velocity and position 6 seconds later. Okay, velocity. So that's 36 minus 18 minus 2. 18 minus 2 is 16 meter per second. And displacement. Position pucha hai na? So position is displacement. Uh, okay, I didn't write 0 here. 0. Okay, let me just quickly pull up my calculator. So 3 into 36 minus 216 over 3 minus 12, 24 meters. Okay, that was example 5. Let's quickly move on to example 6. Says a particle P moves along the x-axis in the positive direction. The velocity P at any time is given is 0.03 t squared. When t equals to 5, the displacement of P from the origin is 2.5 meters. Find an expression in terms of P for the in terms of t for the displacement. So whenever I want to find displacement from Vt, I have to integrate. So I integrate plus c. Now, how do I find this plus c now? I'm given a coordinate. What is that coordinate? That when t equals to 5, the displacement was 2.5 meters. So yeah, and it's saying in the positive direction. So I'm guessing that it's going to be, forward from to forward 2.5 meters. I'm going to say 0.25, 2.5, 0.03 into time 5 cubed over 3. So that's 0.01 and 125, 1.25 plus c, that's 1.25 plus c, 2.5, c comes out as 1.25 meters. Okay, so what is my expression then? It's 0.01 t cubed plus 1.25. Then part B says find the velocity of P when its displacement from O is 11.25. And when it's my displacement from O, so I'm going to say that 11.25 equals to 0.01 t cubed plus 1.25. Okay, so I'm going to try to solve this. 10, so it becomes 1,000. So t is therefore cube root of 1,000, which is 10. Okay, find the velocity. I don't have the velocity. 3 meter per second. Okay, any questions? This is repetitive right now. It's going to change in a little bit. I think this question is tough. And then we have another past paper question, a few other past paper questions. Okay. Yes, these are interesting questions. Let's talk about this one. Now, please pay attention to this one. It's going to tell you a lot. Let's say I will on the exam. This is probably a 6 or an 8 mark question. Okay, it looks very short, but it's a long question. It says a particle moves forwards and backwards along the line so that its displacement as meters from O is given by uh, from its initial position is given by 2t cube minus 12t squared plus 18t. Find the distance that it travels in the first 5 seconds. Now notice that I've asked you to calculate the distance that it travels in the first 5 seconds, not its displacement after 5 seconds. So if 5 laga ke answer nahi aa jayega, this is an 8 mark question. I'm telling you right at the start, which means that you'll have to, sort of do a bit of a struggle and or a 6 mark question. You'll have to do something and come up with the final answer. Now, what am I really appealing to in this question? What concept am I talking about here, which complicates this question? Can anyone take a guess? सही है, the particle is turning. Abir is telling us that the particle is turning. So अबीर वो पहले कैसे फाइंड करेंगे, उसके लिए डिफरेंशिएट हमें करना पड़ेगा. हम डिफरेंशिएट करते हैं, हम कहते हैं 60 square minus 24t plus 18. Now this is a quadratic equation, which means that the particle is turning twice now, probably. Okay, so let me solve the quadratic equation on my calculator and see if I get my answer correct. 6 minus 24 and 18. So I'm getting T as 3 and T as 1. Okay. So what happened was that at time 0, the particle started from its initial position, and how do I know whether it was moving forwards or backwards? I will still have to find that out. Um, can I find that out? How do I find that out, whether it was moving forwards or backwards? Calculate displacement at t equals to 1. I know that at t equals to 1, the particle was turning. So it will determine, that's the first time it turns. So I will know if it had gone backwards or forwards depending on velocity, depending on what its displacement was. Let's find out what its displacement was. I think it comes out to be 20 minus 12 is 8 meters. So what happened was I moved 8 meters forward. Okay. Mohit, I couldn't have seen the sign of the velocity because उसका मसला ये था कि velocity एक function है, it's not just a number. Aryan, if I find the displacement on every second, the complication that will be कि जरूरी नहीं है कि 1 second के बाद तो turn हो गया ना, so I can't 0.5 पे check करना पड़ेगा and so on. सही है, I can't really go on and directly say anything about it. Okay, so at t equals to 1, the particle turned. What happened after that? How far it turned again at t equals to 3? How do I find out where the particle was at t equals to 3? I again do this. Alian, that's going to be very challenging for you to find every second, and in this case, it might work. When I have turning points in decimals, it might not work for you. Okay, that's interesting. Uh, 0 meters. So what did it do at 3? It came all the way back. Okay, it came all the way back. T equals to 3 हो गया. फिर क्या किया particle ने? What do you think happened after that? It turned again. Okay, it turned again, and now it's going in what direction? It's going in the positive direction. अब वो 5 पे कहाँ पे गया है, ये भी फिर से पता करना पड़ेगा मुझे. So 2 times 5 cubed minus 12 times 5 squared plus 18 times 5. Okay, so 2 times 145 minus 12 times 25 plus 18 times 5. 40. So 40 meters away. So what's the total distance traveled then? The total distance traveled is 8 plus 8 plus 40. 56 meters. So whenever you see a question which looks very simple on the start and it has a lot of marks, please make sure that you look at it carefully and sort of come up with a good solution to it. in the book also you can see that I've given you an entire page, which means that it's not a one line answer. It's a proper working and everything. So you have to show me all these points that you found out. You cannot just simply put it on a calculator and give me a final answer. That is the working for this question basically, that you found out distances at each and every point. Okay, let's take you to the next question. We have three more questions for today and we'll wind that up. This is a past paper question from June 13. It says a particle P moves in a straight line. It starts from rest at a point O and moves towards a point A on the line. During the first 8 seconds, speed increases to 8. Um, with constant acceleration during the next 12 seconds, speed decreases to 2. With constant deceleration, P then moves with constant acceleration for 6 seconds, reaching A with a speed of 6.5. Sketch a velocity time graph. So this is something from, I think, the first part of the chapter, and we'll draw it again. It's the last part which makes it important for this chapter, and when we'll talk about that. Okay, okay. Could you have done the last question in a different way? Do you understand if I say this, that what I had to do was I had to integrate with limits from 0 to 1 first, then from 1 to 3, and then from 3 to 5. What if I tell you this? Okay, because the graph is not in front of you, but you know that when you calculate and what equation would you integrate? You would integrate not s, you would integrate the vt equation. You'd say 6t square minus 24t plus 18. Does everybody understand what I just said? I could have also found the area by splitting it into three parts and saying that you can come up with the final answer just by doing integration with limits. The only thing that I have to be careful about is कि ये वाला answer जो है वो एक negative number आएगा. So you have to be aware of that कि I can mix the two ideas together. Last topic में हमने जो है वो पढ़ा था कि हम जो है वो VT ग्राफ के नीचे का एरिया निकालते हैं तो हमारे पास डिस्प्लेसमेंट आ जाती है, डिस्टेंस आ जाता है. सो वही कॉन्सेप्ट मैं इधर भी लगा सकता हूँ. यहाँ पे ग्राफ मेरे सामने विजिबल नहीं है, बट आई नो दैट आई कैन स्टिल कैलकुलेट द एरिया अंडर द ग्राफ ऑफ अ VT function if it's a quadratic or a curve or whatever the case may be. Okay. Okay. A particle moves in a straight line. It starts from rest at point O and moves towards a point A on the line. During the first 8 seconds, speed increases to 8. Okay, I was sketching a velocity time graph. It starts from rest. Okay, started from rest. Okay, I also want you to look at this question carefully. It might be a little confusing for a lot of you. Okay, into it. With constant acceleration during the next 12 seconds. So time हो जाएगा 20. Speed decreases to 2. With constant. P then moves with constant acceleration for 6 seconds, reaching A with a speed of 6.5. Do you all understand this graph? This is the velocity time graph. Okay. Then it says this displacement of P from O at time t seconds after P leaving O is S meters. Okay. The displacement of P from O. Okay. Shade the region of the velocity time graph representing S for which for a value of T which is between 20 and 26. Now S is what? It's the displacement. So yeah, and I want you to pick out a random value between 20 and 26. Call that T. So yeah, let's say I call this value T. Okay. This value is T. Uh, okay, I've done something wrong here. Wait. Let me draw this again. No one's noticed. Okay. Would decrease kidney speed and I didn't do that. So 8 and 8 with constant during the next 12 seconds. Speed decreases. There's no constant velocity. Okay. Is this a decrease like that? 20, to reach 2. And then there is an acceleration again. It reached 26. Okay, that's the correct VT graph. No one noticed. Okay. The displacement of P from O at time t seconds after P leaves O is S meters. Now, for a value of t between 20 and 26. So you could pick out any value of t. I said it's somewhere between 20 and 26. I don't know what value. It could be 23, it could be 24, it could be actually 26 itself as well. It doesn't matter. But the real question is, what part shade or should I shade? Shade the region of the velocity time graph. What part should I shade? That's the question. Anyone tell me what part should I shade? Hmm. Any ideas? What if I shade this? Is this correct? अब मैंने अभी जो T choose किया ना, it's less than 26. You could if you chose that as 26 and you're saying I should shade this one, okay. But what I wanted to now understand, Abir, is that I'm not asking you the distance traveled between 20 and 26. That is this. What am I asking you? I'm asking you the displacement from O between T0 and T26, T something between 20 and 26. So मैं O पे कब था? मैं O पे तो यहाँ पे था, ओरिजिन पे। ओके, जब टाइम जीरो था, तो ये सारा डिस्टेंस जो है मैं ओ से दूर जाता रहा। आई वॉज ट्रेवलिंग अवे फ्रॉम ओ, एंड व्हाट पॉइंट डू आई नीड टू स्टॉप? आई नीड टू स्टॉप एट अ पॉइंट बिटवीन 20 एंड 26। तो मैंने एक आर्बिट्ररी रैंडम वैल्यू बीच में ले लिए, और मैंने कहा मैं पूरा ये शेड करूंगा और कहूंगा कि this is the displacement from O. All of this distance is the displacement from O. It's not just one part of the uh, graph. Okay, does that make sense? And you see, it's a 1 mark question. Okay, can I take you to the next part now? That's a 6 mark question. मुझे बताओ, what should I do? Show that for t between 20 and 26, s equals to this. Alian is asking, can't we shade the whole area under the graph because it represents the displacement? Yes, you can do that too. I don't mind that. Okay, मैंने एक random value t क्यों रखी है? I'm just going to explain that to you in a little bit. Okay. Show that for t between 20 and 26, s equals to this. तो अब कोई रैंडम वैल्यू है बीच में टी की, और मैंने आपको एक फंक्शन बना के दिखाना है, मैंने एक्चुअल एरिया नहीं कैलकुलेट करके दिखाना, बिकॉज आई एम नॉट टेलिंग यू व्हाट वैल्यू ऑफ टी दिस इज, यू विल probably not be able to find for me a solid value, a number, but you will be able to calculate a function. Where do you think I should start this question? It's 6 marks. How do I prove this to you? How do you get an st function from a vt graph? What should I do? T0 T देखो, T has to be somewhere between 20 and 26. It's not 26, it's not 20. अगर 26 तक फाइंड कर लोगे तो टोटल डिस्टेंस आ जाएगा। एरिया कौन सा है अवकाशा? That's the question. हाँ, तो ये अब ये वाला एरिया कैसे फाइंड करूँ? मुझे तो T की पोजीशन ही नहीं पता। कैन आई स्टिल से दैट कि अगर मैं यहाँ पे VT की इक्वेशन बना लूँ, कैन आई फाइंड द इक्वेशन ऑफ द VT ग्राफ? ओके, मैं इक्वेशन ऑफ द वीटी ग्राफ बनाता हूँ. कैसे इक्वेशन बनाऊंगा? आई नो दैट दिस पॉइंट इज 26 कॉमा 6.5 एंड दिस पॉइंट इज 20 कॉमा 2. सही है. तो पहले मैं ग्रेडियंट निकालता हूँ. 4.5 divided by 6, 3 over 4, 0.75. Okay, y minus y1, mx minus x1. So I'm getting v equals to 0.75 t minus 13. Now look at this. If I wanted to find this random area, could I have said कि मुझे इसको इंटीग्रेट करना चाहिए? वैसे तो आइडियली लिमिट्स के साथ करना चाहिए, बट अभी नहीं भी करना तो मैं जो है वो उसके साथ इंटीग्रेट कर लेता हूँ. वैसे अच्छा, अगर इसका एरिया फाइंड करना होता तो मुझे इसको वैसे लिमिट्स के साथ इंटीग्रेट करना चाहिए, नॉट विदाउट लिमिट्स. ओके, सो लेट्स सी व्हाट हैपेंस व्हेन आई पुट लिमिट्स. क्या लिमिट्स लगानी चाहिए मुझे? t0 से t20 तक. ओके, s equals to 0.75 t square over 2 minus 13t. Okay, and the limits are what? Okay, no, I shouldn't integrate with limits. It's going to complicate things. Okay, I don't want to do that. Let's not do into limits. Let's talk about something else. Okay, let me make this simpler. It's going to get very complicated if I do limits. 0.75 t squared minus 13t plus c. Because वो function जो है वो पीछे से discontinue हुआ है, it's a discontinuous function, I can't do this. Okay, how do I find this plus c? ये s बन गया, sorry, ये s बन गया. How do I find this plus c? Any ideas about plus c? अब देखो, मैंने पहले भी कहा कि मेरे पास कोई कोऑर्डिनेट होना चाहिए इस ग्राफ के ऊपर कि भाई ये जो डिस्टेंस कवर हो रहा था, ये जो डिस्प्लेसमेंट टाइम ग्राफ का फंक्शन मैंने बनाया, इसका कोई कोऑर्डिनेट होना चाहिए. सही है. तो मैं क्या कर सकता हूँ? व्हाट आई कैन डू इज आई कैन फाइंड यू अ कोऑर्डिनेट एट t इक्वल्स टू 20. कैन यू टेल मी व्हाट s वुड बी? पीछे वाला फंक्शन तो सारा डिसाइडेड है ना कि यहाँ तक इसी तरह चला है, 20 तक इससे और कोई डिफरेंट नहीं चल सकता. सो मैंने कहा कि मैं इस ट्रायंगल का एरिया निकाल देता हूँ, हाफ इंटू बेस इंटू हाइट, और ये 32 हो जाएगा. सही है. और फिर मैं इसका भी एरिया निकाल देता हूँ, हाफ इंटू हाइट इंटू सम ऑफ पैरेलल साइड्स. Okay, that gives me 60. So can I say that I have a coordinate which is t20 and s60 plus 32, which is 92. इनिशियल कुछ नहीं होगा, इनिशियल तो जीरो था ना. ओके, सो ये देखो. Okay, let's see if we get the correct answer. 202 चाहिए ना मुझे. ये डिवाइड बाय 2 भी है, सॉरी, आई मिसड टू डिवाइड बाय 2. Can't we input s and t as 0? बेटा, s and t 0 रख दोगे. The problem with this S and T keeping zero is, you see, इसके तीन अलग अलग फंक्शन है. इसको इंटीग्रेट करोगे तो अलग ऐसा आएगा, इसको इंटीग्रेट करोगे तो अलग ऐसा आएगा. इसको इंटीग्रेट करूंगा तो अलग ऐसा आएगा. The s is not standard. So for this one, yes, you can do s equals to 0 and t equals to 0. I'm just doing a calculation here. 202. Sorry. Yes, t equals to 202. Okay. So s equals to 0.375 t square minus 13t plus 202. It's a tough question, not an easy one, which is why there are 6 marks for it. And sometimes these questions get tough. Okay, you have to think about कि भाई मैंने अभी क्या किया है. मैंने जो है वो इस फंक्शन का s निकालने के लिए the displacement at this point I wanted to find out what the displacement is during this part of the journey. What I had to consider was कि पहले कितना distance जो है वो cover हो चुका है. If I couldn't find that distance, I couldn't find an answer for you, because that distance covered during the first 20 seconds will determine what the next part of the journey will be. Alian, read the question. It says shade the region, the velocity time graph representing S, representing displacement for a value of t, where t is between 20 and 26. I've marked any random value between 20 and 26. If you change this number, let's say आप कहते हो 23 लेंगे, तो मैं कहूँगा कि हाँ अलग एक displacement आ जाएगी. 24 लेंगे, एक अलग displacement आएगी. But I don't want you to come up with a number. I want you to come up with a function. So that's the relationship between the second and third part, which is why it's asking you for a random value of t between that. The idea is कि ये सारा shade होना चाहिए to indicate displacement. Okay? Okay. Let's look at example number 9. It says a particle P starts at the point O and travels it in a straight line of time t seconds after leaving O. The velocity of P is 5, is this, where V equals to this. The positive value of t for which the acceleration is 0. I think acceleration find करना तो simple सी बात है. It's 3 into 0.0625. 0.187 t squared. Okay, so acceleration is 0. So I factor out a t, 0.1875 होगा. I think I added an extra 0, 0.1875. Okay, so either t equals to 0 or 1.5 minus 0.1875 equals to 0. 8. Okay. So acceleration is 0 when t equals to 0 and t equals to 8. Remember that I'm right now talking about acceleration, I'm not talking about velocity. Let's see what part 2 says. Part 2 says the distance traveled by p before it changes its direction of motion. So I just have to find one particular type of distance, but I will have to find when it changes its direction of motion. That's the first thing that I should find out. So I will equate v to 0. Okay. T squared common. So either t squared equals to 0 or 12. So after 12 seconds of motion, the particle changes its direction. I want to find out what I want to find out the distance traveled. So मुझे कुछ ज़्यादा मेहनत करने की ज़रूरत नहीं है. Now since it's a continuous one directional motion, I can say that I can just go on and do 0 to 12. And what function should I integrate? I should integrate the velocity function. I should say 0.75 t squared कि इसके नीचे area निकाल रहा हूँ, this area between the curve and the x-axis. And when I find that area, that should be equal to the distance traveled in one direction. अगर वो direction change करेगा तो हाँ फिर वो positive negative वो सारे मसले create होंगे, which is why then it's better to split the limits first, calculate separately, and then find out and draw a diagram and then do it. जिस तरह मैंने पिछले question में किया था. Okay, so I'm just going to use my calculator to do the integration part because we're running out of time and this meeting is going to end. Um, okay, so function integration 0.75 x squared minus cubed. Okay, the limits are 12 and 0, 1, 0. Okay, I can come up with a final answer like that. Let's quickly look at the last question. Um, Okay, I think we are going to run out of time on this. So I'm going to end it here. In case the last question bothers you, can do that as part of your homework. If that bothers you, I will solve the homework as well. So you can see the questions there. If there are no other questions, we'll end the class here. No? Then you can leave. Thank you.